Hello, my name is Clinton David, a data scientist at Oxford Policy Management. Welcome to this presentation. I'll talk you through how you can automate your workflows with Webhooks and Plum API. Why should we automate data workflows? 1. Automation ensures each step is executed the same way every time, and this reduces variability and improves reliability. 2. With automation, validation and integrity checks can be built into the process to catch issues easily. Thirdly, once set up, automated workflows can run with minimal human supervision, hence saving time. So this is the architecture overview of our workflow. The process starts with a push event to the repository that is hosted on GitHub. And on the same repository, we have a webbook configured. So this push event will trigger webbook, which in turn sends a payload to the Plum API that's hosted on our server. HMAC verification is done by the API, and if it fails, a message is sent back to the webbook configuration on GitHub. If it's successful, proceed to do another check, which is to see if this payload was triggered by a push event to the main branch. If it's not the main branch, a message is sent back to the webbook configuration on GitHub. If it's the main branch, then now we proceed to invoke the bash script that in turn triggers other workflows, such as updating your dashboards that are configured on Shiny Server. So what's a webbook and what is a GitHub Webbook? A webbook is an event-driven communication method that automatically sends data between applications via HTTP. GitHub Webbooks provide a way for notifications to be delivered to an external web server whenever certain events occur on GitHub. For this to be set up, you need endpoint to which the payload will be delivered, then the trigger or event to invoke the payload. So how do you set up the webbook? First of all, navigate to your repository on GitHub. Secondly, go to Settings and then click on Webhooks. The resulting window, click on Add Webbook. Put the payload URL, which is the address of the server hosting your Plum API, and then select application.json as your content type. And then finally, put your secret and remember to configure the same secret on your server where Plum API is hosted. On your Plum API, this is just an example. You will load your libraries and initialize the log file, and then define the HTTP post endpoint, and now extract the payload from the request, then extract branch information as well from the payload, and then load the secret from the .env. What's HMark? In full, HMark stands for hash-based message authentication code. This is a method for verifying both data integrity and authenticity of a message. It combines a shared secret key with a message, e.g. webbook payload, and applies a cryptographic hash function, SHA-256 in this case. If even one character of the payload changes, the HMark output changes completely. HMark is used to confirm that a message genuinely came from the expected source and that it wasn't tampered with. So what is SHA-256? This is a widely used cryptographic hash function that generates a fixed 256-bit hash value from the input data. In the context of HMark, SHA-256 is the hashing algorithm applied to the secret and message. So now put together How does GitHub Webooks relate to HMark and SHA-256? So what happens is, when sending a webbook, GitHub includes an xhub signature 256 header. This is the HMark SHA hash of the payload, computed using the shared webbook secret. The receiving API, Plum API in our case, recomputes the hash using the same secret and compares it with the one from GitHub. If the hashes match, the payload is authentic. If not, the payload is rejected as potentially malicious, and in our case, we do not proceed to invoke the bash script. Why secure your endpoint? 1. Ensures only GitHub and not a random attacker can trigger your workflows via webhooks. Secondly, prevents spoofed payload from executing sensitive actions like triggering deployments or refreshing data pipelines. So how do we secure our endpoint using HMAC verification? Extract the SHA-256 signature from the GitHub payload as shown in the screenshot. And then secondly, recalculate the HMAC using the shared secret. We will use these two variables, that is, the signature and the computed signature. Now, so how do you trigger your workflow? So first of all, you use the two variables that I've mentioned before to validate the request using the HMAC signature. If the validation fails, we send back a message to our webbook configuration on GitHub. And then we can as well log the information to our log file on the server that's hosting our Plum API. If it's successful, we can now proceed to do the next check, which is to check if this payload was sent by a trigger from the with a push event to the main branch. If it's successful, that is, if it was a push event to the main branch that triggered the webbook, then now we can invoke the bash script using the system function. If it fails, we can send back a message to our webbook configuration on GitHub. So how do you check your webbook logs? On the webbook configuration page, you can find details of the status of your deliveries. As shown on the screenshot, you can see the address of your endpoint and an icon message showing if it was delivered successfully or not. So to access your webbook logs, click on the address of the webbook. You will see the settings and recent delivery sections. Click on recent deliveries and you will see details of your webbook such as the payload, headers, and the response. Finally, this is a sample bash script. In my case, I had set up the workflow to update dashboards that I had deployed on Shiny Server. So what this bash script does is to simply do a git pull, which then updates the code that powers the dashboard. Thank you for listening. That's the end of our presentation.